general relativity step by step. In screencast 49, I was defining a path with a tangent vector u equals my tangent vector between 2 points lambda equals 0 and lambda equals 1, and I defined it to be a geodesic if du by d lambda equals 0. So what that was trying to say was that the tangent vector itself was constant as you moved along the curve. I'm going to generalize that ever so slightly now. So I'm going to say that du by d lambda, actually I'm going to generalize it in another way as well. I'm going to take it from a to b, shouldn't make much difference, equals some function of lambda, which is of course a scalar, times u. So before we had f of lambda equals 0 in screencast 49, we said f of lambda equals 0. Now I'm going to change it to, I'm going to generalize it slightly. And it might look like I've lost all hope here, but I haven't. It's because the tangent vector here and the tangent vector here are the same thing. So the kind of thing it allows you to do is, if I've got my path from lambda equals a to lambda equals b, it might be moving along like this. It might be moving very slowly here and then very quickly and then very slowly and then very quickly. But in either case, we've got the rate of change of u is in the same direction as u itself. What we can't do is have a tangent vector that's got a component not parallel to itself. So this is in fact a useful equation. So let's just write it out. What have I got? I've got, what I want to say is that du alpha by d lambda is now equal to du alpha by d lambda plus, might have written the wrong type. Yeah, I should have written a d there, I guess. Capital D, I mean. Plus Christoffel symbol. Oh, I'll do it in Romans. So there's a, and this one's a to match it. We've got a b and a c downstairs. dxb by d lambda, dxc by d lambda equals f of lambda, before we had 0 of course, times dxa by d lambda. There's quite a lot going on here. Let me just make sure I've got everything right. I'm so delighted by this innovation of changing the colour. I'm going to make the free index A red, there and there, and I'm summing over the blue ones and the green ones. So I'm going to sum over a blue B, there and there, and also a green C, there and there. Wonderful stuff. Okay, so this is a sort of generalized version of the geodesic. This is a generalized version of the geodesic. And we've got a new word to play with. If f of lambda equals 0, we say that lambda is an affine parameter. Affine. I never know whether to say affine or affine, but I say affine parameter. Okay, and so there's a nice little generalization of the geodesic curve that we covered last time. And we'll see that this is a bit more of a general and powerful technique. Okay, I'm going to stop there. Stop.